All right, let's kick this bad boy off. Oh, no sound. Wait. Welcome to the Rick and Morty Virtual Reality VR Lessons Learned with Owlchemy Labs. That's my face. My name is Alex Schwartz. I'm the CE Owl of Owlchemy Labs.
I'm Devin Reimer, CT Owl of Owlchemy Labs. We made a job simulator, which ended up shipping on the HTC Vive, Oculus Touch, and PlayStation VR. And we're here today to talk about our next project, Rick and Morty Virtual Reality, that we worked on with partnership with Adult Swim.
So I want to kind of go through the origin story of like how did a project like this even come about. So let's get into that. But first, just a warning, there are spoilers for the actual game itself. And in addition, the show is rated mature, and so there's lots of swearing, and therefore the game is rated mature and has swearing, and therefore the talk about the game about the show is going to have swearing. So let's get into it. So I guess the way that this all started was Justin Roiland, who actually is the co-creator of Rick and Morty and also does the voice for Rick and Morty, got a early Vive from Chet in the early pre-days. And he started tweeting about, oh my God, Job Simulator is so much fun. I'm having so much fun. And we hadn't even released the full game. We only had this kitchen demo that we were giving out to developers. And so we tweeted back at him and said, yes, we have to get together and like hang out. You make my favorite show. It's amazing. And so we ended up messaging back and forth. And like him getting a Vive had articles all around the web. It's like, oh my God, creator of Rick and Morty has a Vive. And so our plan was we were going to be in Hollywood for a convention, and we're like, let's go meet up with Justin and let's pitch him on this crazy idea that he'll probably say no to, which was, what if we had something like Job Simulator in the main iconic area of Rick and Morty, Rick's garage, just room scale, hand interaction. That's about as deep as the pitch goes at this point. And so we actually had Justin play some of the new levels that were work in progress, and so I have a video with sound here of him trying the like 15 seconds of new Job Simulator levels.
Oh my God, what the fuck? Holy shit. Oh shit. Oh my God, you guys, shut up. Oh, it's like fucking Flappy Bird. Like the same kind of shit in Rick's garage, just like you guys said. Are you fucking kidding?
So clearly unimpressed. And only a short amount of time after that, we were down in Atlanta at William Street, pitching the concept to the heads of Adult Swim. Dan Harmon was there, some cartoon characters were there. And soon after we were actually working on the game. It was pretty amazing.
So that's the origin. Now let's show what the final result was. This is the 30-second trailer that we made for the game.
What is this, Rick? It looks like some sort of crazy video game about us or something.
It's not just a video game, Morty. It's a virtual reality game. I sold our likenesses to some video game publisher for a lot of money, Morty.
I mean, who's gonna play this?
You're gonna play this, Morty.
What? Oh my God! You killed it! I mean, me!
VR for everyone! Everyone with the box on their face, Morty! It's raining money here in VR land! It's raining money! Ha ha! Wubba lubba dub dub!
So that was on television.
So like all of our games, we built this in Unity. In Job Simulator, we built this tech that we call Owlchemy VR. It's like our fundamental interaction layer that sits on top of Unity. So we ended up having this baseline tech to work off of. It required a lot of new features for Rick and Morty, and it required a major refactor to completely decouple it from Job Simulator, so it was a standalone framework. So when we ended up kind of thinking through what this game would be, very clearly in our heads, it was Rick's Garage. Rick's Garage has all these fun things to interact with. We love interacting with things with your hands in VR, so this is very clearly a win. In Job Simulator, we ended up building the environment specifically for the gameplay. So if people have played Job Simulator, you know that it's around one room scale space, and so you interact with everything around you, and we designed it very specifically for that. But in Rick and Morty, we had this very iconic garage that people that have watched the show know what it looks like, and clearly it's bigger than one room scale size. So how are we going to resolve this? We can't just shrink the whole garage down, otherwise it's going to feel like a phone booth. So we knew we needed to kind of solve this locomotion problem in the game. For people that have come to our talks before, you know that we are not fans of artificial locomotion. It causes comfort issues and accessibility issues with people because it makes people feel uncomfortable and sick. Traditionally, teleportation in VR is done in a few different ways, but a primary one is something that we call granular teleportation. So you point in a direction that you're going to go, and you click, and then you go there. It's very easy to drop into a project and be able to move around in it, but it ends up having some problems. And for the stuff that we like to build, it isn't a super great option. So what it ends up doing is a few different things. In our testing, it makes people stop moving around. So people, because they can go anywhere just by pointing and clicking, they end up locking their legs, standing in one spot, and not moving. This ends up leading to fatigue. This might be counterintuitive. They're like, oh, but if I'm moving around lots, that's going to lead to fatigue. It turns out standing in one spot with your knees locked is actually really bad, and people don't want to play experiences for long periods of time. But if we get people to move around even a little bit, it ends up extending playtime. And on top of that, it ends up being way more fun to move around in real life. The problem is with granular teleportation is you can get yourself into a lot of bad situations. So this video here is a bad situation of the kind of the edge of your real world bounds problem, where you've teleported over to something and over the time of playing you've drifted towards one of the edges, and now there's an object that's just outside of your reach because you might have a physical wall there. This becomes quite problematic because the actual solution to solving grabbing that object is to walk away from it and then teleport again to then move towards it. And it's very counterintuitive. And then also, it takes you out of the game or piece of content completely, because now you have to start thinking about your real-world constraints instead of what's actually in the game itself. So for Rick and Morty, we came up with this kind of different approach that we refer to as zone-based teleportation. So we ended up dividing the garage up into these zones, and so what you end up doing is you look in the direction of where you want to go, and you hit the button to teleport, and you teleport into these zones. And your position is relative to your real-world position inside of your play space. So it ends up being super easy. You don't have that finicky, oh, I'm almost there, I've got it quite right. It's just, I'm going to this zone to interact. It ends up encouraging movement, because once you're in that zone, now it's up to you to move around within your real local space to actually reach things and interact with them. Within the IP itself, we wanted to kind of ground this, so we ended up making these kind of de-atomizer teleportation things that destroys you in one location and recreates you in another location, and it works really good. A fun fact here is our method is gaze-based. It's not pointer-based. People that play lots of VR games will point just intuitively because that's what they're used to in other content, but you almost always are looking in the direction you're pointing, so it doesn't really matter. And we'll explain why in a little bit we made that decision.
Yeah, so anyone who's seen how Job Simulator, any of the development talks, we talk about the fact that we recreate each of the rooms manually by hand with custom level designs based on whether you have a large room scale space, a medium room scale space, a small room scale space, or if you have a tracking setup that affords 180 degrees of motion, then we make a 180 version that's bigger and a 180 version that's smaller. And so you could see here, we're in the Unity editor in Rick and Morty, and you could see that there are actual this cabinetry that's being remodeled and rebuilt for different play space sizes. We have different laundry machines and different places where things occur because we have to hand level design each separate zone in order to now afford proper room scale in like a large number of different households afforded physical area. So I think an easy way to explain this is to look at it from the top. So first off, I just want to say, like, anyone who's a big Rick and Morty fan might see something that is slightly off from how the actual show is laid out. So I'll show you here. In the television show, the shelf that is shown up at the top is actually located down on the bottom. And so there's a whole set of logic that went into the concept of us moving that shelf to another location. So when we came to the fact that we're building 180-degree tracking setups, you have 3 directions where you can actually face and have tracking. And so in this image, you can see you've got the green arrow showing that if I face forward toward my camera, or if I turn to my left or to my right, I still have valid tracking with my hands. I'm not occluding myself. But if I turn around fully backward, my hands are going to be occluded by my body, and I'm not going to be able to interact with anything. By moving that one shelf, we actually can get to a room layout that allows for 3 valid forward directions, that all interactions are fully accessible to your hands, even on those 180 tracking setups. And so I guess to kind of unpack that a little bit more, we were talking about when you're doing teleportation, we use gaze-based. The reason for that is that imagine you're in that upper right quadrant and you want to go back to the laundry quadrant, you would turn around and you would point and hit the button. But if it relied on your hand tracking, which is going to start losing tracking if you go turn around, then you would have kind of incomplete results and some weirdness. So that's why people are always looking in the direction that they want to go. We use gaze, which has 360 all the time, and it ends up solving that kind of issue there. In addition, there's kind of like, we were talking about teleportation methods that other games use. There's an added extra brain function that you need to think about, which is sometimes they add teleportation with rotation, where you would have to kind of I want to go to this new spot, but I want to be facing a new direction, and so you could turn your room scale, or in some games there's this magic flip that happens. So I want to go over there, and I teleport, and I'm expecting to go just closer to to the location I see, but I end up facing 180 degrees because of the tracking limitations. If you want to be facing back toward the area of content, they have to do this magic flip, and so it's very disorienting. And so we're able to avoid any of those kind of flip on teleport things that confuse people and end up with a nice smooth layout for interaction. Now, the shelf itself is actually pretty funny. So we moved the shelf, we changed the show, but the layout challenges that we came about, there's so many, this IP is so great because it's almost anti-canon in the sense that Rick and Morty, all this parallel universes and crazy stuff. When you launch the game, it's funny, one of the first lines out of Rick's mouth is I had to rearrange the entire garage to make this work. And so we put these scrape marks where the shelf used to be, and just kind of it looks like it wasn't cleaned in that area, and then we move it to the other location. So in case anyone is a super mega fan, they look at the scrapes and they're like, okay, I get it. But yeah, it's a great IP to work with because you can do those types of things and get away with that.
So we have all these 3 quadrants that we talked about here, valid teleportation. That works great, and as I mentioned before, it's relative to where you are in the play space. But now you have this problem of clearance and teleporting into obstacles. So in this diagram here, put red boxes around areas we don't want you to teleport into, because then you'd be standing in a shelf or in this washer or dryer. The way we end up thinking about this is we end up overlapping them. So imagine every quadrant that you can move between, and you slap them on top of one another. This ends up building this available space for standing. And so you can see here, the green represents areas that if you're standing and you teleport to any other zone, you're not going to be inside of a piece of geometry. So we ended up laying out these things very specifically so that it afforded that you wouldn't be standing in those areas when you teleport. And we can only control where the person is so much, so we ended up doing this additional thing where we actually show on the floor this ring showing that you're going to be inside of a piece of inside of a piece of geometry. So people end up just leaning back naturally when they end up coming across it. It ends up making level design incredibly challenging, particularly with our system where we're building multiple different versions of this and then have to think about how these ends up working. We're hey, the shelf needed to flip, for example.
So we're going to go through a couple key elements from the show that we wanted to bring into the game. The first was portals. So hugely iconic in Rick and Morty, the idea that you could maybe physically walk through a portal in VR and step through it would be, it's in the beginning, it sounded amazing to us. We have to make this work. It also gives us the ability to get outside of the garage, which we were taking most of the gameplay and bringing it in a single space, but you do want these other opportunities to leave this area. So we got to do it, but how do we do it in VR? And so kind of walk through that. The first thing is that there are some IP challenges that we were working with. We got this really big IP Bible from Adult Swim about all the Rick and Morty universe, and it had a page actually about how portals function, and they said that it has to be shot onto a flat surface, first of all. And so we're thinking, so when you exit a portal, you could be in empty space, you can emerge, but you have to go in through a solid surface. So we're thinking, if we're in room scale, how do I make a solid wall somewhere inside of my play space that's not at the edge, so that imagine it's right near your real world wall, you want to jump through it and you smash into a wall. So there was a lot of challenge there about thinking through that. And so this video shows exactly how we pulled it off. So I'm going to let it loop a number of times. But when you're in the garage, which is the video on the left, 2/3 of your play space is available to you from the leaving portion. And you walk through that final third of your room scale spot into the new destination. Now, once you end up in the bathroom in this example, the portal wall actually closes, and when you turn around, the new portal wall is back at the other third's location. So you always have 66% of the room scale to be in your starting location and 33% to end up in, which means that you have enough room to step through naturally. It also, when you go through, if you kept the portal wall in the same exact spot, if you went like 1 pixel through and then 1 pixel back, you could accidentally backward teleport yourself. So it solves those problems of like getting messed up inside of portals. The other thing that is a bit magical about how we needed to kind of pull this off and get players positioned is, notice right in the beginning, the player pulls this lever which actually brings the portal wall up. It's very precisely positioned in a way that when you pull that lever, you have to be close enough to grab it, which means we know exactly where you're standing, which means that we can bring that portal wall up so that it's all in the perfect position, and that you can't like go teleport from another spot in and accidentally portal yourself into another world. So this took a long time to get right and was one of the more complex design challenges of Rick and Morty VR.
So now that we talked about, we finally figured out how to make them work. How do we visually and mechanically make them work? So the first challenge was visually, how do we make this work? So one of the first things kind of attempted is what you normally kind of do for portals is you put up a render texture. The problem with VR and how we were tackling this is you need to walk through it, which means that when your face gets really close to it, it would need to be incredibly high resolution, which is a big problem with render textures. On top of that, we got shadow popping issues because we're rendering differently, and we needed to be able to step through it seamlessly with the player not even noticing anything actually happened. The end result ended up being multiple cameras using depth masks. So we ended up having a pretty complicated render pipeline that involved, like for example, rendering your local skybox, rendering your local world, then using masks to render the remote skybox and the remote world, and then dealing with problems with objects that are moving between the two worlds and where they clip, where they pop, because we don't want an object half in and half out the portal because the rendering will look a little bit funny, and how to get all that to work. The end result ended up being seamless. The other challenge we have, particularly because of VR, is generally in games that have portals, the mechanic is you're moving through it and that's it. But in VR, because you have your hands, you can actually reach right through a portal and interact with objects in the other world, which in our game is actually in a completely different location in the actual scene view. So here, for example, is another example of the space scene where you have this floating mask that's in 0 Gs, and when you throw it through, it needs to get the gravity of the Earth and then fall down. So we ended up having to do a lot of work on like conservation of velocities and how throwing felt through portals. And the end result ended up being really awesome and people doing things we didn't expect. Like for example, at some point we've seen people reach through the portal into the bathroom and grab something off the bathroom sink and then pull it back through without actually walking through the portal at all, which is really cool. Now, we got this all built, and now we have to deal with perf. For people that build VR stuff, perf is very challenging to begin with, and now we've introduced this portal, which essentially means we're rendering the whole game again. So we ended up having to do a lot of creative things to solve for this. In this video, you can kind of see some of the things that we are doing as you're looking towards the portal. So the portal has a very iconic style with the swirl, but we couldn't leave the swirl up all the time. Otherwise, you're going to feel like you're walking into a wall. So as you end up looking towards it and getting close to it, it ends up fading so you can actually see through, so you can actually feel comfortable stepping through. But this visual design, which actually made better for VR, was also used to do some performance tricks. So for example, when the portal ends up getting in view, we end up doing things like caching local shadows in the space that you're not looking at, and then only rendering shadows in the other world, for example. And then doing other things like turning off lights in certain places as you end up looking through these worlds. And because most of it ends up taking up your field of view, people don't end up noticing. The next challenge was, now that you're playing the entire game in the garage and you're stepping through these seamless portals, how are we going to end up handling loading? Because this game has some length to it, so how are we going to end up handling bringing in new assets and stuff without actually dropping the frame rate? We did some looking into kind of some async loading stuff, and the end result was to keep the frame rate where we needed to be, async would always end up causing the frame rate to drop. Our end solution was to load the entire game at the start. This was a big challenge to make sure that loading didn't end up getting really brutal, but as an end result, once you end up loading the game, you just can play the whole game nonstop with no interruptions. Lastly, because we're gluttons for punishment, we had a bathroom and we really wanted a mirror. Someone was like, we just crack the mirror and it'll be fine. But it's like, a mirror would be really great. So now we have portals and a mirror, which means that we've got rendering times 3. So what we ended up doing here was we have this technique that as you look towards the portal and the portal ends up taking your focus, we actually disable the mirror and vice versa. And it turns out people don't really notice that that's happening at all because you don't end up putting your head in between the two going like this. You end up turning one towards the other. It ended up meaning that we had no additional rendering overhead because we had to already optimize for portals themselves.
So another case study on interesting design challenge was approaching and dealing with the design of death in VR. So in this game, you can die at any time in any location, and there's a variety of different crazy ways that we didn't even expect people to figure out that you can figure out how to die. We didn't want it to feel punishing. That was the opposite of what we wanted. Also, some games, when they approach death in VR, they pull control away from the player, and I think losing control in VR is one of the worst things you can do. And so we had a lot of challenges here, and so the design of that was pretty funny. So here is a video. This was actually kind of impromptu and not meant to, this was not expected. Someone was throwing a glass bottle into this kind of pit just for fun. And a shard of broken glass came back and killed them. Now, you can see the player got brought to this new world, this purgatory. So in the game, we built this kind of staging area that's part of the IP. It's a purgatory where you get cloned again back into your life as a clone Morty. But the cut between being in the garage and to this new world, it's an instant cut. It's to a new location that has completely different visuals, so it's much darker, different color scheme. Having a very empty world made it a lot less jarring. Like, where am I? What's new in this location? So it's pretty much empty except for a small phone on a little pedestal in the center of the room. Now, remember, you could have been anywhere in your room scale at the time that you died, which was this big challenge of if we put tables and obstacles and items, you might actually just pop instantly into some geometry, which would be the worst experience there. So we made this tiny table in the center of the room, which acts as something to reposition you back to where we want you to be in order to, once you pick up the phone and hear the devil's assistant telling you need to come back to the mortal plane, and you hit the button, you come back. So it lets you have the agency to choose when to go back at your own time. And it's taught in the first few minutes of the game, which was really important. We didn't want it to feel punishing. The first few minutes, Rick actually points a gun at you and says, you know what, okay, you're done as a clone. You did everything you need to do, and he shoots you. And so you get that first moment, and you understand how the process of death works, and that it's actually kind of like a silly mechanic in the game versus you just lost or as some kind of fail state for you.
The next thing we had to tackle was who you were as a player. In Job Simulator, you're human, right? You are you. In Rick and Morty, we wanted you to be a character. So should you be Rick? Should you be Morty? We really knew that we wanted Rick and Morty to interact, and you'd be able to observe that because that's really cool. So we needed to come up with something in this universe. We ended up settling on was this concept of a clone Morty. Because you're a silent protagonist, this kind of helps with that. And also, it turns some of the limitations of VR into the actual joke in the game. Rick refers to you at one point as a floating head and hands, right? So that makes sense in this, like, you've been built and you're this clone of Morty. And then on top of that, because you're this clone of Morty, they can make fun of you as stupider than Morty, which means that Morty can also make fun of you all the time.
Right. So we got to get, we wanted Rick, we wanted Morty, we wanted them fully animated and in the scene with you as characters in VR, which is this incredible challenge. And in addition, this is a 2D cartoon. No one had ever done 3D realizations of these characters, and that was on us to kind of figure out from sheets of reference about how Rick looks in 2D to some kind of 3D representation that wasn't creepy, that you could stand next to and have an interesting time without kind of like uncanny valley nightmare. So that was very tough. There's a couple like character sheets of the phonemes and for the burping animations and mouth shapes. You can see Morty and Rick's rig here, but we had them fully rigged and animated in the scene. We wanted the player to feel present. And so characters will look at you. This is an extreme case where he's just following you creepily. But no matter where you are in the scene, you can get the character to look or not look at you. And we had dynamic pointing. This was a big one. Is Rick delivers some line like "Grab the watch off the shelf," and people are like, "What shelf? There's so much stuff in VR. It's all complicated." When you have one character, just go grab that. It's instant. 100% of people get it. We had through playtesting, we realized that characters directing you via pointing is just 100% for players. And then in the trailer you saw the idea of right when you get into Rick and Morty, the first thing that people do, a lot of people, is they see Morty or they see one of the characters and they just want to slap them in the face and see what happens, right? Like instantly test the boundaries of what's possible. And so 90% of the way through development, the first 90%, we had no reaction of any kind and your hand just passed right through the characters because they're fully animated. It's really hard to dynamically do this. Late stage, we added Final IK and Puppet Master, which is essentially like a dynamic ragdoll tech that allows for, like pushing a character physics-based off axis, and they'll kind of conform back to where their pose is supposed to be. So you could see someone really playing around with that a good amount. So throwing underwear. That was actually one of the things that we wish we had kind of dug deeper on and didn't have enough time for because it came in so late. So first off, this introduced a ton of perf overhead, and it was very buggy. When we added it, it broke a lot of parts of the game, and we needed to fix it. But it kind of feels disappointing even at that level because there's no funny quips, so there's no real reactions to that interaction. And so we don't like to disappoint in that regard, and I think that's one of the places where we could have gone a lot deeper. So these characters, though, they need to come alive via the voice acting of the show. VO is so important in the Rick and Morty universe. So our writing pipeline was actually really funny. So what we would do is in-house, we would record a first pass of temp VO. And so Andrew, who is right there, you can see here on the top, is recording some lines that Rick needs to say and Morty needs to say. And we would use that temp VO, like a rough approximation of Justin's voice, to put that in the game and use that for active play testing. And so we needed to figure out, what are the right words to say? How does this work? How does it all kind of play out? And then we'd figure that out, and then we'd pass it over to Justin. And so I'm going to show you kind of the line that Andrew recorded.
Hello, Morty, you must have done a shit job when you tried to fix the car. We broke down and we need you to help us get out of this mess. Open up the portal wall so we can bring you here.
And so that gets passed over to Justin, and he adds his kind of flavor and riff track on top of it, and you end up with...
Hey, Clone Morty, you useless piece of garbage. You must have done a real shit job when you tried to upgrade the car. We broke down and we need your help to get us out of this mess. Open up the portal wall to the new location so we can bring you here.
Notice that Justin's was a lot longer. So that was one of the interesting challenges, is that when you add kind of the stuttering and the funny pauses and the comedic timing and all the riffing, you end up with much longer VO. And so that became a challenge. And in fact, we talked all about the challenge of the writing process, directing, focus, and VR. When you have VO that's too long and you get kind of fatigue from standing there watching a character speak at you for minutes on end. We talk all about that in spatial storytelling, which is actually on the GDC Vault. And tomorrow you should check out the Building Believable Characters in VR talk here at Unite at 2:15 tomorrow, where we're going to go into building believable characters.
From a game design perspective, in Job Simulator, we had a really strong premise, but wasn't really a full linear story. We knew Rick and Morty needed to be different. It needed this real linear narrative. We wanted to tell what would end up being a complete episode of the show. So to tackle this, we decided to go down the path of creating this open sandbox, but with gating puzzles that ended up leading you through this story. One of our first case studies is the Youseeks. So Youseeks is a really popular character and my favorite from the show. So we knew we really, really wanted it in VR. For people that have not watched the show, the way the Youseeks works is there's a box with a button on it, you hit it, a Youseeks spawns, and then you verbalize what you want, and the Youseeks does that. There's a problem in VR is you can't really talk to a thing that understands exactly what you're saying and does it. So we needed to come up with a different approach here. We started thinking about how this could work and what inputs you do have. And one input you do have is moving your hands and your head and directing. The end result was something we call Youseeks. So you hit the box button, you get a ball, you throw it, spawns Youseeks, and now it's mirroring your actions. So it's this mirror mode character. And this allows you to do some interesting things, like in this video, for example, you toss it out in the driveway outside of your available play space and use it to toss objects back to you. And you can spawn multiple of these things and do some really crazy and interesting things. This presented some unique challenges, one being personal space. So as this character is coming at you and moving like a human and entering your personal bubble because it's mirrored, so as you get closer to it, it gets closer to you, you end up feeling uncomfortable. And on top of that, if you end up moving close enough, you start clipping through geometry, which feels really bad in VR. So we need to come up with some solutions. The first one I'll show here is we realized that wouldn't it be funny if you just pulled off the HMD of the Youseeks? And it's obviously it explodes because coming out of VR is too hard. And then we wanted, what happens if you get really close? So what about the hug? This ends up feeling all right in VR, surprisingly enough. You notice in the video I talked about pulling off the HMD, so you can reach out and pull it off, but then we also realized that what if you just went like this to yourself and pulled off the thing, because essentially it's mirroring. So we ended up supporting that. It felt really good and allowed you to destroy Youseeks outside of your play space. They could be really far away from you and you just go like this and it would destroy them.
So the next case study of a mechanic in the game was the watch. So this is a historic part of our development process. I'll go through it. Is one of the first things we prototyped in the game was to make a watch on your wrist that you would interact with Rick. And so it's one of the first things we prototyped and we threw it out. So part of it was that we weren't sold on the interaction method. In the early days, you had to actually grab the watch and you'd pull up and it would kind of reveal a hologram of a character. And it required this handed interaction that was not very natural and people didn't really get it. And so it went away. And then we started to kind of work through the design of the game and went many, many, many months forward. And then we got to the point where we said, okay, we need this hint delivery system, some like VO delivery system for the times that Rick and Morty are out adventuring and you're back in the garage. And so we thought, okay, let's put like a speaker on the wall, and then the speaker will be like, they could speak to you over mic. And then we started adding the portal tech, and we went through to other worlds, and you're out like in a space battle. And then now the speaker that was back in the garage is over there, and I can't listen to it because I'm too far away. And we're like, if it could only be on your body somewhere. And we're like, the watch. So it was so silly that we kind of threw it out and then came back to it in the end. We ended up doing gaze-based, which is actually how you look at a damn watch. And that was like, hey, whoa, we figured it out. And so you could get all these VO hints and info drops no matter where you are in the world. And it actually was another, like, we had learned this lesson earlier, but we kind of forgot, and then it came back, which was in Job Simulator. We built most of the game and got very close to the end, and people were complaining about the fact that when I finished a task, the next one just came right after that, and it was the next thing to do and the next thing to do, and it's just the game's barking at you to do more stuff. And so at any time, you could be screwing around in the world and like just kind of playing with various physics features of the game and ignoring what it's telling you to do, but no one wanted to do that. Everyone was just rotely following the rules. And so we added this mechanic of pulling a ticket in the convenience store, or pulling the next task in the office, or pulling the chain in the automotive shop. And that was all added to add kind of like a level of gating and timing and agency to, yeah, I'm ready to pull the next task. Even though there's no difference in how the game worked, just adding that one little element that is like, when you're ready, pull the ticket and you can go. Now people felt comfortable to stop and smell the roses. And we had done the same issue in Rick and Morty. We forgot about that. And so the watch ended up solving that kind of feeling of Rick's just telling you to do the next thing and the next thing and the next thing. And so we added these kind of like, all right, when you're ready, like screwing around, and when you're done with that, like give me a call back on the watch. And that let people feel comfortable to explore and just have on their own time. So another good solution for that.
So yeah, long story short there is just because you've thrown out an idea doesn't mean it's bad. Maybe that implementation was just bad.
Yeah. Another study on something that we spent a lot of time on that was very strange and ended up changing throughout development was this concept of, everyone knows like scale in VR is really great, and we want to do something interesting there. And in Rick and Morty, you've got multiple occurrences of going into tiny worlds. So there's the episode where you go inside the human body and you scale down. And then there's the Microverse with the battery. But we're thinking like, okay, shrinking, we don't really know what we're doing. We'll go into some kind of world where you're tiny in a petri dish and start playing around there. That was our initial prototype. It didn't really solve any of our problems, and it kind of just sat there. And then we thought, okay, wait, the Microverse episode. There's this whole concept that when you go inside, there's a world that generates itself. So there's these people that are pedaling, and this whole entire universe that Rick created inside of a battery is actually what's powering the battery. So that was the joke. So you don't have pedals, you don't have feet, you can't do that in VR. But we thought, okay, we have hands. We want to do something also from a game design standpoint that's like revisitable. I want to keep coming back to it, something skill-based without punishment. And so this idea of what if you're actually generating a universe by doing this kind of like little puzzly timing game. You could see, most people probably didn't even see what was going on as they charged this battery that gets end up used in various places in the game, but you're generating an entire universe through hitting these buttons, and then it gets plopped inside of the battery to power it for you. And so that ends up going into all these other mechanics, like you need it for the space station, and you need it for these other places. So ended up finally solving that, but we spent many, many months not really knowing what we wanted to do with this part of the world, and it ended up getting changed, and we threw out a lot of code and prototypes in the process.
So in Rick and Morty, there's this thing called the Combinator. I refer to it as the best and worst thing that we built. It's the best because it's awesome. It's the worst because it was the hardest thing that we built in the whole game. We had this idea of crafting. So in Rick and Morty, Rick is I'm going to put a bunch of things together and build cool things. So we knew we wanted something down that vein. It presented a huge problem. So in VR games that we build, we try to make sure that everything you think you can pick up and interact with is allowed to be picked up and interact with, which means that we have a ton of items inside of our game. And traditional crafting systems, some of the ways they end up handling the problem of how many different combinations of things is they reduce the number of things you can craft together. Right? As the number of that goes down, the number of possible combinations also go down with it quite significantly. Some other systems, what they do is they have lots of failure states. So it's like most things produce garbage, some things produce success. In VR in particular, it was really terrible to go spend time grabbing physical objects, moving them over to a thing and combining them, and then getting junk that you didn't want. This is actually physically tiring, and if you get junk a few times in a row, people stop using it. In other systems where you're clicking on some menus and it's very fast, people are willing to try lots of different things to see if they can get something exciting. It just didn't work here, and it more often than not disappointed people. So we knew we needed to kind of revisit this in a different way. So the end result was, what if we just combined every single object? So there was no failure state. Every two objects in the game, you put them together, would create something interesting. So what we ended up doing is when we thought maybe this is a thing we should attempt, we sat down with a spreadsheet and started writing down every object we had in the whole game on one axis and on the other axis, and starting to be like, oh, how would this work together? What properties would work? This turned into a giant nightmare. For the amount of objects we had in the game, this meant that there was approximately 30,000 first-order combinations, meaning that every prop needed to apply either geometry or materials or some sort of different interactive properties to those objects. And the way we ended up handling that was every object has kind of a priority order based on what it ends up changing. Like maybe this one material, changing this one material is really important, so it gets sorted to the top. So essentially, you can combine two things and then end up getting a result. As I mentioned, first order combinations of 30,000. Now that you've created a new thing, you can put that back on the Combinator with other things. So you know this explodes exponentially. So in this example here, this is kind of a simple depth example. So in Rick and Morty, if you take a carrot and you combined it with some glass, you get a glass carrot. Now if you take that glass carrot, you combine it with a hammer, now you get a hammer with a glass carrot on the end of it. Now, if you take this glass carrot hammer and you combine it with a Youseeks ball, and then you throw the Youseeks ball that it creates, you get a Youseeks with a glass carrot hammer for hands. So this ends up becoming very challenging. So that spreadsheet I mentioned, so we needed to QA this and then make sure that everything created something interesting. So we needed to actually test every combination and make sure we supported everything. This was... So it was somewhere around here we realized maybe we are making a very bad decision and maybe this is the wrong way to go about this. But then we came across this tweet from Scribblenauts. So it talked about how the belief in Scribblenauts is there's this fantastic AI and it ends up doing all this data-driven stuff, so then it takes guesses and actually builds things. But the reality of Scribblenauts is it's just mostly hand-edited, created stuff. So we're like, okay, maybe this is just how the magic is made. So we ended up just leaning into it and doing tons of manual work. But the end result is you put anything on there, you get something interesting. And people make lots of crazy things, and lots of crazy things that we have never even seen before, just simply because there's so many possibilities. It ended up being super, super rewarding to do in VR. And people return to Rick and Morty a lot to go and just mess around with the Combinator. And we've seen so many Let's Play videos. Someone's just like, oh, I want to see all the permutations of poop, for example. And they would just make an entire video about that, and it's super awesome.
Worth it. All right. The next thing that I want to kind of dive into is the concept of Roy. So everyone knew Roy. It was this, for anyone who hasn't seen the episode, there's in Blips and Chits in the arcade, there's this VR headset that you could put on your head, and then you live the entire life from birth to death of a human being, all within the span of a couple seconds. And then when you come out, you've just lived this entire life. So clearly, we needed to make this in the game. Everyone on the internet clearly, they're like, this will be a big disappointment if we don't have it. We wanted it in the game, but it's a scope nightmare. It would take years to build something even close to that. So we set on that mission, and we ended up coming up with something called Troy, which is like the intergalactic ripoff version of Roy. And the joke is kind of like, yes, the ripoff was all these cardboard cutouts, and you do live the entire life of a human with all the branching decision-making and all this kind of craziness that can play out. But the asset creation ended up being extremely fast and easy to do. Well, relative easy to do hundreds and hundreds of different situations. But these constraints actually led to a hilarious result, and it's a lot of fun. A lot of people told us that playing through Troy was a delight. And so there's these tons of branching situations. You can, like in the beginning, you could end up being like the sporty teen, and then you catch the football in the air, and then you end up living a life. You go into drug abuse, and then you end up dying early. And it's like you play all these different combinations. Like, how many things can you actually do in here? People are freaking out online. But we were using we had this knowledge of a game that we had built previously called Discourse, where the entire game was about wildly branching narrative in Unity. And so we used some of our techniques from that to apply it to Troy. And so we had actually a developer working on this, and the temp VO, this is a fun fact, the temp VO that he was recording, I think, with his laptop microphone and doing all the voices of all the characters, male, female, whatever it was, that was the temp version, and then we kept that in and shipped it because it fit with that joke of like the intergalactic ripoff. So everything that you hear from every character, that was Graham. So good job, Graham, you shipped that in the game. Another issue that we had was in both Job Simulator and Rick and Morty is the concept of balancing accessibility with wanting to have kind of complex interactions in the game. So take Job Simulator, for example, which there's a fire extinguisher is one of the good examples, is where you think, I clearly need a second button on this controller. If I'm using trigger to pick everything up, I need like grip or something to activate the fire extinguisher. And so there were a couple different examples where we said, no, let's bake it down to a single button so that we don't have to teach people the mapping for a second thing. And so we added a physics-based like fire extinguisher where you push on the top, almost like a clown, big button on the top, and it would shoot the fire extinguisher, liquid. And then, for example, the mouse on the computer in the office. Originally, we thought, okay, you'll grab the mouse with your trigger, which is what you do in the whole game, and then use some other button. And then we ended up doing a zone-based capture method where when you put your hand inside of this space where the mouse pad is, it kind of gets absorbed by the mouse, and then your trigger acts as the click. And when you move your hand outside of that area, again, trigger is grabbing. And so you end up with one button, and no one notices that. Everyone just puts their hand in there and starts clicking, and it just works perfectly. So we were able to get it down to one button in Job Simulator, which we were proud of. And then we got to Rick and Morty, and it's like, okay, now we have another set of examples where we really want two buttons. Turned out both of them were guns. The first one was kind of like this fan service kind of joke where we really want Rick's laser gun in the game. And so we have it on the desk, and it's like, we got to do something. And so our solution here, I'll just play it.
Initiating reverse safety.
So yeah, you pick up the gun and it says reverse safety, and it's like, okay, you detected it's not Rick, it's just gonna start shooting wildly, and so it starts shooting and they throw it out of their hands. And it's like, cool, we joked our way out of that, but now we have a real situation where we wanna do like a shooting mini game arena where you've got cannons, blaster cannons. So we're like, how are we gonna do this? We need a second button. And so again, we designed around needing a second button with some creative options. So here's what happens. You get told that you need to go fix the spaceship out somewhere, and so you go through a portal, and now you're there. The portal closes behind you. Most people don't notice. It never comes back. You're in this space scene, and Rick tells you, okay, you need to put your hands on these pads, and then your hands turn into huge blaster cannons, which is shown here. So, and you just start shooting wildly, and you're in this crazy shooting situation. And it turns out that the only way out of this scene is to get killed. So you end up changing the hands back to normal hands at the end, thus not needing to have a second button to drop guns, thus stayed with one single button all the way through.
When it comes to floor-level interaction, in some experiences this can be good, but on some platforms or tracking setups, it can be problematic because sometimes tracking doesn't actually get all the way to the floor. So we needed to come up with a solution to handle this problem. So one way that ends up being solved in a lot of titles is this kind of like force grab, where you like point your hand at something and you click and it like comes right at you. This creates a lot of problems. One of them being it stops people from moving again. Now that you don't have to actually move to grab something, people just stand completely still and they just like interact with the world like this. And it's not what we wanted to do. So we decided to kind of figure out how do we end up solving this floor-level interaction problem in Rick and Morty. In Job Simulator, what we did was we ended up putting these triggers on the floor that detect every object, and then it goes through and determines its importance, and then it goes and like, oh, moves everything up onto shelves. In Rick and Morty, in not every zone do you have a nice shelf to put something on top of, or sometimes those shelving units are full, and there's a lot of objects in the game. So we knew this wasn't a total fix. So we ended up creating a levitation system. This levitation system, the way that it works is you end up putting your hand above an object on the floor and it levitates up towards you, not into your hand. It's still up to you to physically reach towards the object and grab it. So we're teaching the exact same mechanisms that you would interact with things on a shelf, but it's only for floor level things and they just come up towards you.
Just run it. Is that the video?
Oh, video.
Video. There it is.
This ended up working surprisingly well, so well in fact that while we only implemented it on Oculus 180, we're thinking about in future titles, maybe this is like a default thing because it does help with accessibility, and grabbing things off the floor continuously actually is quite fatiguing. There's a lot of things to solve because we still want to allow people to do floor level interactions. So how do we kind of solve that where people sit down on the floor? We're doing a lot of thinking about this because we think this is actually an interesting thing going forward. Alex mentioned earlier about all these different Playspace sizes that we make, and it's a big challenge to actually lay them out, but QA becomes incredibly challenging. So one thing we ended up accidentally shipping with was this bug where people are like, I can't finish the game because I can't high-five Rick. And it's like, okay. So it turns out there's a part of the game where progression was that you just gave Rick a high five, and it worked in all of our testing. But it turned out on certain Playspace sizes, the animation for Rick's hand was just outside the Playspace bounds. But when we ended up doing QA for all of them, because it's a quick motion, all of our testers ended up putting their hands just lightly through the actual chaperone bounds and not noticing it. But for these particular players, they actually had a real world wall right there, so they couldn't continue. So this is something that we're now thinking about is how do we end up writing software that allows us to test this better to make sure that we catch these use cases where the actual tester ends up not noticing that they actually reached outside their physical bounds. As I mentioned before about recycling objects out of your space, we still have a recycling system in the game because just because you can grab things off the floor and all that's fine, sometimes you actually can chuck things out of your space. And we've noticed in VR, people like doing weird things and like taking this thing that the game told you is super important and opening the window and chucking it out. So we end up having to do some things like, for example, we have all these recycling systems and triggers around that detect when things enter them, and then things at any given point in time have a certain priority assigned to them, and it's like, oh, that's not important because you could just get another one if you want. Or, oh man, this thing is like literally one of a kind and I need to get it back. In those cases, we have specific spots that they teleport back to, so you always have access to them. And then another mechanism, so we didn't have to teleport everything back, is we end up having this computer in this scene there. So for example, in this video, you're taking the skull and smashing it, so it's not that it went outside of your play space, it stopped existing, and the person went and just reordered it on the computer.
We also had this, the age-old video game design issue is like, if you have a doorknob, it has to be openable. Otherwise, there's this incredible disappointment of like walking up to it, pulling it, and then nothing happens. And that was pre-VR, it's just like, this has to be, there's a social contract. You can't put a doorknob, it has to be locked. And so we had this doorknob that's in the show. And right through that door is the rest of the Smith household, right? Like you want to go walk through the living room and everything, and you can't because we clearly weren't going to model and do all that. So the great way to do it was to joke our way out of it. So you pull the doorknob, real fake doors. So people look at that and they're like, ha, and they throw it away, and then they smile and they move on. Whereas you would have just disappointment when you grab for a handle and it does nothing. So you gotta always think about something. So the question that we keep getting over and over is like, how was it working with Adult Swim? So I think a lot of people have heard stories of like working with big IPs and it's like this nightmare. It was absolutely incredible working with Adult Swim, and I think the key here was this really mutual level of trust, is that we were big fans of the show. They knew that they could kind of say, like, we could do this justice in the medium that we know so well, and they provided us all this great support. So I think building the relationship on trust was kind of the key part of this.
When we ended up starting this project, at the time there wasn't any really big IPs in VR. They were actually building a standalone VR experience. So we weren't sure what kind of people were going to expect, and we've taken this really iconic show that people love in 2D, bringing it to 3D into VR, and how was that going to be received? So one of the greatest compliments we've ever received is the amount of people that come to us and say, we played Rick and Morty Virtual Rick-ality, and because of that, we started watching the show. That's just a fantastic thing.
Yeah, that's a great thing to hear. And so, yeah, we couldn't have done it without the help of the whole Owlchemy team and Adult Swim Games. That is it. Thank you. So anyone with questions, please feel free to step up to the mic. Could someone flash us the number of minutes that we have left for Q&A? Is it about, that's 10.
10 minutes.
10 minutes.
Great.
Also, the person with the best question by the end will get a JobBot plushie. Good luck.
All right. Great talk as always, guys. I just wanted to maybe get some help with implementing portals. I did basically the same implementation as budget cuts. And I got that all working using a depth mask, just like you guys did. Only it happened when it came time to fill the hole left by the mask. The built-in skybox system doesn't fill that in because they use the skybox as a way to clear the buffers, right? So even using the component didn't really work. Did you guys use your own separate skybox, separate from Unity system for that?
Yeah, we actually have a camera that renders out a separate skybox because we wanted it animated.
Okay.
Well, and it's not Unity Skybox. It's a piece of geometry set to background queue behind everything.
Gotcha.
I think that's probably the way to go.
Okay, yeah, that'll do it.
Thanks.
So when you put together the different level designs based on the size of the space, did you guys do that with kind of a procedural or algorithmic process, or did you just manually make like a ton of different versions? And if that's what you did, how did you go about that?
Absolutely manual. We built everything by hand. The thing that we used in Job Simulator that was a good example of this is like, you actually, in a small laundry room, you would, well, in a larger laundry room, you'd put your washer and your dryer side by side, for example. And then in a smaller one, you'd get vertical mounted ones. And so you actually have to, you can't just scale things down, it'll feel weird. You have to redesign for each size. So what we built is a in-editor preview tool, which I showed like flipping through. And so we would do that and then set our chaperone bounds to our like minimum sizes and cycle through them and make sure that everything was reachable on this and that, and just do a lot of testing and watch for things that went outside of the play space.
Were they prefabs, or was it some other kind of data structure?
So I guess like there are prefab swaps. There are things that get hidden and replaced with like a smaller version or a slightly different version. And then there's all positional moves. So this item needs to go from here to here, and that's why we're storing in the editor kind of like a whole set of metadata about the small size. So put this here, hide that, change that, and then when you flip it, it goes and automates all those operations so that you don't have, you know, garage small, garage medium, garage large as separate scenes. Then good luck making a change. It's trickle down nightmare.
Yeah, thank you.
Yep.
Hello. First of all, I want to say I'm a big fan of both the Game Job Simulator and that, and you guys did a great job on both those. And then another thing I noticed you guys do a great job is, at all your talks at every Unite, is creating efficiencies. So not just cognizant of the gameplay, but even internally in a team. So how do you tackle like cross HMD development, like, you know, Oculus and you got Vive and all that?
Tons of tips there.
Yeah.
I'll start with one, which is like everyone has an HMD at their desk. And we think that's really important for the process of building VR games. Is it doesn't matter what discipline you're in, you need to be testing your content in VR all the time because it's so specific. And if you have teams remote or teams outside that are just contributing content and praying that it works in VR, you're going to end up with tons of problems. So that's one.
We built, very early on when we started in VR, we realized that this was going to be, there wasn't going to be one headset that was going to rule them all. There was going to be this entire like multi-platform approach that was going to have to be taken. And luckily for us, we had done so much multi-platform stuff on mobile and PC before. So we ended up writing all of our code in ways that essentially it just branches according to the platform. And for all of our titles, what we end up doing is it's one Unity project. That's it. There's no, you go into this branch to do this, custom thing. It's everything is written in the same project, which ends up leading to a lot more work initially. But in the long run, essentially, it's like you have to add a feature or fix a bug. You just fix it in one place, and then that goes across all different platforms.
And then we try also not to kind of leave development of one platform as like a rigid unit and then move to a second platform. We try to constantly be testing whether the functionality that we're building is working across multiple as we're doing it, because it plays into the design and development of it. It can't be an afterthought.
Yeah.
Okay, thank you.
Did you guys ever think you would resort to 2 buttons, and will you in the future?
I like the word resort because because it shows like a strong commitment to not wanting to go down that path. Yeah, I mean, resist as long as possible.
Yeah, it's definitely a common factor across like platforms, and we don't know what future platforms are going to look like, and so requiring the least amount of like buttons on the controller kind of future-proofs things too. So that's kind of one factor, and then the other factor is just like teaching players. We try to like bake the tutorials into the game that you don't realize you're doing a tutorial, and then the more you add more complexity like that, the more challenging that becomes. So
yeah. Well, and to be clear, I mean, we do have teleport on trackpad and grab for trigger, so it is 2 buttons at this point with Rick and Morty. So we'll see where it goes, but we don't want it to balloon because every extra step and thing you need to teach and remember means that a new user just has to kind of grapple with that as their starting point.
The last thing we want is like the PlayStation and Xbox controller problem, where it's like as the consoles went along, they got more and more buttons, and developers were like, I got more buttons, I should use more buttons. And now a modern game is just almost unplayable by somebody that hasn't played games before. I want VR to be completely approachable to everybody.
Great talk, guys. Quick question. How do y'all go about structuring y'all's playtesting? Where do y'all get the playtesters? And at what point do you decide, like, oh yeah, this feature's not working, we need to take a step back?
Figuring out when something's not working, I mean, really comes down to like subtle cues of someone looking disappointed or being confused, and just playing through that with new people over and over. And so like getting those new people in the door is part of the process. Well, first off, it's not hard to convince people, hey, do you want to try an unreleased VR game at our studio? Like that goes really well. But you have to really structure those tests in a way that ensures that the developers who are actively working on the content are the ones seeing the results from new testers. Because again, you become your worst tester very quickly in VR. And so like always staying in touch with this the true test of whether this worked or not is someone else, not us, is really important. So we try to keep that really close to like the core development process is bringing people in, having new folks, and watching them very closely and analyzing like their emotional response to stuff.
Do y'all record the playtestings for like future reference?
So as Alex mentioned there, we always have a developer there because we find recording just doesn't get all the data that you need because it is watching the person's movements and all that stuff that actually like bakes into the whole thing. So also we discovered that having a developer that worked on that, seeing someone struggle is one of the greatest motivations ever because you just sit there wanting to scream at them to like how to fix it, and then that's some pretty great motivation to make sure you don't have to do that again.
Yeah, and it's the same thing at conferences, is like showing it at a conference and watching people have trouble. Like you can easily convince yourself that this is good enough, and then watching person after person after person fail to, get a certain cue, you're like, no, it's not them, clearly. It's that we need to make the cue better.
Yeah, and one thing I should add there, in Rick and Morty, we had a new problem when it came to external testers, was in Job Simulator, we could put somebody in a room for an hour and let them play a single job and have an idea. This is like an entire game that goes over many hours, and VR is fatiguing. There's a limit on a human. You can't just like put them in there and say, play this entire thing in one shot. So what we ended up doing was we ended up having kind of like a snack break time. So it'd be like, okay, we're gonna have a snack, but it's a little bit challenging because the first thing someone wants to do when coming out of VR is talk about all the things and ask questions, and then you're just like, here's a snack, and I'm not really gonna talk to you because that would spoil the test. So that's one thing we ended up doing, but it's a bit challenging in VR in particular.
Yeah. And that's a deep rabbit hole too, of like, you could go on for many hours about how to properly like demo VR and all the different things that you learn when you've done like hundreds and hundreds of onboarding and offboardings.
For those of us who teach VR, in addition to the games and stuff that we develop ourselves, a lot of us, initially when people ask, how should I go about making room scale stuff, we just tell them to watch your Unite and GDC talks. And so you've done a lot already to sort of share techniques that have worked well. It's sort of been, I guess, our marquee title of how to do it. You mentioned that you have the Owlchemy tech internally. And for those of us who are trying to find the equivalent of like Owlchemy off the shelf, a lot of us use VRTK. Do you have any plans to make the stuff that you built into some kind of developer-facing thing, or even a user-generated content kind of building kit? Not because that Combinator wasn't nearly complex enough. If only you had user-generated content tools where people could use your actual Owlchemy snap together like Lego creations of VR interaction.
Yeah,
You guys thought about that?
I guess one thing we found is that building a tool for yourself is an entirely different world than building a tool for everyone to use out in the world that can adapt to all different types of games and all different types of content. So that's such a huge challenge over and above just like making it work internally when we kind of get it and it kind of work in our very specific case. So it's a tough one, and it takes a lot of time and effort. So we have anything to announce about that, but it seems like a lot of devs have kind of started with a baseline of something and pulled it apart so much and have been using it over time that they've kind of like gotten their thing that does similar stuff. I've seen many studios that have a somewhat cross-platform hand abstraction tool that they're using, and when you put enough time into it and you battle test it and ship it in one or two things, it's like, even if there was a great product that did it and I could buy it today, like we probably wouldn't change because we know it and we've got our stuff working. So it's a tough problem. I mean, standardizing tool sets in VR is like a thing that needs to happen, but it takes time and someone to really commit to being a tools company.
Well, thanks for teaching us how to do it. Independent of tools, the techniques really help a lot.
Thank you.
Thanks. Thanks. We're done. All right.
That's our thing.
Thanks so much.
Wait. Cool.